Okay, so I thought I'll do some of this homework with you. So the first question is $4 to $6.50. So we know that in order to make a ratio, we can't have any decimal points. We need whole numbers. That means that we need to convert this to cents. Now, if we convert this to cents, we need to convert this one as well. Now, we know that there is 100 cents in $1. That means that we need to times both sides by 100. So 4 times 100 equals 400 cents. And $6.50, to convert it to cents, we times it by 100 cents and we get 650. So now we have a ratio. Okay. It's obvious here that we need to simplify this ratio. Now, we don't need to use our times tables because we know what that one number is that goes into both numbers. You'll notice that the last two digits here are 00, and the last two digits over here is 50. So definitely 50 will go into both numbers. And just to prove the point, you'll notice when we write the multiples of 50, we can see that either the number will end in 2 zeros or 50, as you can see. Okay, so we know that 50 goes into both numbers because, as we can see, we've got 400 over here and 650 here. So they're both in the multiples of 50, so 50 will go into both sides. So we write divide by 50 on this side and divide by 50 on that side. So 400 divided by 50, if we count this way, 1, 2, 3, 4, 5, 6, 7, 8. 400 divided by 50 equals 8. And 650 divided by 50 equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So your final answer should be 8 to 13. So the next question is 2,500 liters to 2 kiloliters. Now we have a table over here which tells us how many liters there are in 1 kiloliter. So there's 1,000 liters in 1 kiloliter. So we need to convert this number here to the smaller measurement. So we need to convert the kiloliters to liters. Remember, we always convert to the smaller measurement. So in this case, we know that there is 1,000 liters in 1 kiloliter, but we have 2 kiloliters here. So that means we need to times this by 1,000. So 2 times 1,000 is 2,000 liters, and we already have liters over here, so we don't need to convert that, so we can leave that as is. So now we have the same measurement, and now we can write it as a ratio because we have the same measurement. Now we don't need to use our times tables again because we know what that one number is that goes into both numbers, because obviously we need to simplify this ratio. So the number that goes into both numbers here is 500. So how many times does 500 go into 2,500? Again, if you need to, you can even write it out. So this is actually the multiples of 500. So we can see that 500, let's just divide both sides by 500. So 500 goes into 2,500 how many times? 1, 2, 3, 4, 5. So we can write down the number 5, and 500 goes into 2,000, or 2,000 divided by 500 is 4. So that should be your final answer. Okay, so the next question is very similar to the previous one. We have 2,500 meters this time to 2 kilometers. So again, we have a larger measurement over here. We need to convert it to the smaller measurement. We know that there's 1,000 meters in 1 kilometer. So we times the larger measurement by 1,000, so we can get this measurement into meters. So 2 times 1,000 is 2,000. We can leave this as is because it's already in meters. So we can bring it down, and now we can put this as a ratio. Again, we know that we have to simplify, and that one number that goes into both numbers equally is the number 500. So we divide 500 by both sides, and the answer we get is 2,500. 2,500 divided by 500 is 5, and 2,000 divided by 500 is 4. And now we can put this as a ratio, and this should be your final answer. Okay, so the next question is 30 cents to $1.50. We know that we need to make this amount smaller because the dollar amount is a larger amount than the cents. Now, we know also that in $1 there is 100 cents. So all we have to do to make this amount into cents is we times it by 100. And I'm not sure if I told you, but the decimal will move to the right according to how many zeros there are. So there's 2 zeros here, so the decimal will move once and then again twice. So $1.50 times 100 is 150. So now we have this amount in cents. This one over here is already in cents. Remember to make sure that when you write your final ratio, you don't include the measurements, right? So you just include the whole numbers by themselves. So now we can go ahead and write the ratio, which is 30 to 150. Now this obviously needs to be simplified, so let's bring up our times table. Oops. Okay, if we have a look at our times table, we can see that there is a number 30 over here and a 150 over here. So in this case, it's in the multiples of 15. Unfortunately, the times table only goes up to 25. The highest common factor for these two numbers is actually 30. But let's just assume that you don't know that. Not a problem. So you go back to the times table and you see that, okay, so 30 and 150 is in the multiples of 15. That means 15 will definitely go into both these numbers. So 30 divided by 15 is 2, and 150 divided by 15 is 10. So let's write that down. We have 2 and 10, and then again, we need to simplify this one more time because we didn't use the highest common factor. So we know though that the number 2 will go into both numbers equally, so the common factor is 2. So then we just divide both sides by 2, and then we get 1 to 5, and that should be your final answer.